Guten Tag und willkommen zum Gang 5 in der Vorlesung Gegenwartsarchitektur im Wintersemester 23/24. Dieser Block hier widmet sich dem, was wir eine digitale Architektonik nennen. Und es ist vor allem die Arbeit und die Perspektive des Lehrstuhls für digitale Architektonik an der RITA in Zürich, die den Hauptinhalt darstellt in diesem Gang für Sie. Ich habe Ihnen 4 Kurzsequenzen aus einem Online-Kurs von Prof.Ludger Hovestadt eingespielt und möchte nur ganz kurz hier ein paar rahmende und einleitende Worte sagen. Ludger Hovestadt ist Professor für Informationstechnik in der Architektur. Das hier ist die Webseite des Lehrstuhls. Sie können hier die Hauptreferenzen finden, die Themen, mit denen sich der Lehrstuhl beschäftigt. Es ist ein Forschungslehrstuhl, der während nahezu 20 Jahren bis zu 17 Forscher beschäftigt hat in den Themen künstliche Intelligenz und Architektur. Und was die Perspektive von diesem Lehrstuhl sehr stark auszeichnet, ist eine Auseinandersetzung mit dem, was Abstraktion ist. Die Essenz, könnte man sagen, von den Erfahrungen und der Arbeit wird gegenwärtig veröffentlicht. Die ersten 2 Bände sind bereits erschienen über die digitale Architektur. Und aus diesem Inhalt jetzt gibt es 4 Clips, die diesen Gang für Sie ausmachen. Und es geht in dieser Perspektive darum, dass die Architektur nicht einfach ein Feld neben anderen ist, ein Feld des akademischen Arbeitens, was abgegrenzt wäre gegenüber der Physik und gegenüber der Kunst und gegenüber der Philosophie und so, sondern dass in der Architektur immer eine Art Synthese passiert des State of the Art, also einer gegenwärtigen, könnte man sagen, Verfasstheit des Weltbildes. Das heißt, die Mathematik, die Physik und die Technik geben uns ja ständig einen erweiterten, einen veränderten Zugang zur Welt. Und es geht darum, wie wir wieder lernen können, dass genau das der Inhalt ist und war, der in den Traktaten, in den Büchern der Architektur klassischerweise erörtert, erkundet, kommentiert und orchestriert worden sind. Die 4 Clips unterscheiden in einem ersten Schritt die projektive Geometrie und wie man damit architektonisch denkt, von der sogenannten stereografischen Perspektive und wie man damit Architektur denkt. Jetzt können Sie, ich will Ihnen ein paar Schlüssel geben, die sehr einfach zu memorieren sind und die Ihnen helfen werden, sich zu orientieren, wenn Sie schauen. Die Projektion geht mit dem Raumdenken zusammen und die Kernidee ist, dass wir den Raum hören und nicht sehen direkt. Ja? Der Raum ist ja eine Gleichzeitigkeit. Also der Raum ist das, wo die Zeit nicht ist. Aber dennoch passiert natürlich ganz viel im Raum. Der Vortrag spricht immer von den Ears, die Ears of Space. Koppeln Sie das mit dem, was als projektive Geometrie beschrieben wird. Und umgekehrt, wenn es um die stereografische Projektion geht, um die stereografische Geometrie, dann denken Sie sich die Augen der Zeit, die Eyes of Time. Weil hier geht es darum, wie verschiedene Geschehen im Raum orchestriert werden können, also in eine Zeitlichkeit gebracht werden. Sie haben also die Eyes of Time, mit dem können Sie Architektur in der Zeit platzieren, und Sie haben die Ears of Space, und mit dem können Sie Raum denken. Beides ist natürlich quasi geerdet, kann man sagen, durch die Weise, wie die unterschiedlichen mathematischen Vorstellungen sich in der Technik, in der Physik realisieren. Um diese Zusammenhänge gehen die Vorträge, und ich bin sehr gespannt zu lesen und zu hören, wie Sie damit umgehen. Es sind recht stille Vorträge, die brauchen etwas Weile und Konzentration und Ruhe. Und es geht nicht darum, dass sie quasi eine Anleitung zum Handeln erhalten, sondern es geht darum, einen Denkraum zu eröffnen, der viele Anschlüsse für sie bereitstellt zu einem Denken, was lange Zeit sehr tragend und selbstverständlich war. Es soll also nichts Esoterisches sein, aber dennoch sind es Größenordnungen, in denen die Zusammenhänge herausgestellt werden, die heute nicht mehr so oft in dieser Kombination thematisiert werden. Viel Vergnügen damit.
Welcome to this new primer on digital architectonics. This is a comprehensive version of the work and the teaching I developed the last 2 or 3 years, and which is available in detail on YouTube with about 100 hours on lectures and tutorials. So, but now with Corona, we developed a new format, because lectures are always about improvisation and needs feedback, and I'm very unhappy just talking to a computer in a freestyle way, like in a lecture. So if in principle content is available on internet, we need a more comprehensive thing. It should not take too long, because you can go back and forth. It should be much more connected to the original sources. You should be interactively able to work with it. And this is what I present to you this semester. So it's comprehensive. It's a recap of the whole story. I want to pack it into one semester, which is quite challenging. And I want to give content to the internet and actual discussions with you to the lectures and the seminars. So therefore we will have discussions and live discussions, present or via Zoom remote. And we have the content on pre-recorded YouTubes. So what is the motivation to talk about digital architectonics, whatever it is, in our specific way? And what can you expect with these lecture series? So me, I'm architect, and I'm quite familiar, because all my life I'm in computer science, in architecture. I never was interested in computer graphics this much. I like graphics, but I think this is not a key question in architecture. Architecture is about jointing, as the name tells, joining things. And this is not the result presented as graphics. Presenting it in virtual reality, for example, or in game engines, or with these glasses, or in high resolution renderings, is a kind of rhetorics. It's not the key of the architecture itself. I think we can address, that's very important, this is what you can expect, that I think addressing questions of artificial intelligence is the key to a kind of digital architecture, of understanding and making architecture for today. So, this is our motivation for this class, or for our kind of teaching. We succeeded in 2006 winning a prize in an architecture competition with a fully automatic architectural design. So this is not spectacular. We can find it here. So it's online. And we have it here in a book. of all our experiments. We had been very impatient. We did a lot, all the range of things what you can do in architecture. We covered that the first 10 years of our research at ETH. So, and for example, this Turing test is here. These are, it's the development from a layout which is not working properly to a properly working layout. So you see all the generations, 3D models, and this is an example, not the example of the competition, another example how it might look like. So the architecture is not too spectacular. I think spectacular is that you can win a Turing test. Which means anonymously experts in architecture are not able to distinguish between human-made architecture and machine-made architecture. So we have been very proud with that. Oh, there's a Chinese version of this book available. Good. So we have been very proud of it, of course, being able and succeeding in this with this technology. But surprisingly or not, nobody liked it. The students didn't like it. My colleagues, there was no discussion possible with my colleagues. Maybe today it's a little different. It was 2006, 2008, we worked on that. And even companies, so architectural offices, developers, real estate agents, and so on, nobody, they all had been afraid of touching this kind of technology or these kind of arguments. This was a little surprising or frustrating. There was the chance, so we had to decide whether to go to underground and just make it 100 times a year, or, and this is what we did, ask the principal question, and our class will follow this question, and there is no answer for it. That's very important. So what is architecture if machines successfully can do what we think architecture is? So that's our question. And for the last 10 years, we thought about that in principles of architecture, in theory, in philosophy, in mathematics, and computer science. So we wrote a series of books. They're available in this environment. And if I want to summarize in two hypotheses what all this is about and why architecture is important today, then we first say the first hypothesis is the 20th century is a digital renaissance in strong correlation to the 15th and 16th century in Western culture. And code today, so coding, especially the lambda calculus, and we will focus on that and explain that, what it is, plays a role of drawing in Renaissance. So as in Renaissance, the architecture is not thinkable without drawings or perspective drawings, which hadn't been developed before. I would say 20th century from 1880 to 1920 on is not thinkable without the idea of coding. So I don't think coding is a phenomena of post-war from 1916, 1918 on, or now with the Internet of Things, with mobile devices from 2000 on and so on. Now I don't think it's a recent phenomena. That the key problem is not the actual technical implementation. It's a certain way of thinking, and this came around 1880 to 1920. And the most prominent thing is quantum physics, which is quite different from the physics and the mechanics as we know and learn at school and from Newton. Newton-like physics. It's radically different, but similar. That's interesting of that. So and in architecture, it's just what we experience in art and architecture around 1920 with the international style, with Bauhaus and so on. I think this is architecture of code. So we will go in detail to that. And we can learn of that, and we emancipate from all these historicity of reading with Gideon or Panofsky and so, trying to bind these things back in these old schemes. If you think the international style of architecture in a quantum way, I think this is adequate, and this directly emancipates you from these very dominant presence of computing and cybernetics today. So therefore, I think there's no architecture thinkable without drawings in Renaissance, and I think everybody would agree. And as it is in Renaissance, I would say there's no thinking without code about architecture today. What you expect, what you can expect is it's not a simple story I want to tell you this semester, and therefore you have to be a little patient. So all the implications of quantum is there's no cause and effect. You know that from physics. So therefore the learning is not that I can tell you step by step and then there is a kind of theory. There's not a theory what I can tell you. So it's more like learning a new language or going to swim, learning to swim. Just jump into the water and try to swim, or trying to ride a bicycle, or learning a new instrument. So you have to train it. You have to get used to it. You have to start to embody a new skill. So that's what all this is about. Therefore, it's a lot of repetition. And in the beginning, for you, it must be super strange, like the first time in cold water. And over time, you will get used to it, and then you are different, with a different set of skills, and you can articulate your architecture in a different, and I think in a more adequate way. So I can just that this is not an esoteric setup. I want to refer to this excitement all around. So, and I think we as architects, we have to address these things. And we as architecture, if we learn how the people, our predecessors and the masters of Renaissance did it, and they faced, I can tell you, they faced very similar problems. So I want to give you some references and about the hustle today and what we are. So what I, as an European, I really are very astonished about the strong belief in California, especially in California, about the innocence of technology. So, and the principal suspicion of towards human intellect. So, which implies always, not explicitly, but implicitly, that if you decide and not the machine, implicitly, then you get dirty. So, and then you have these crazy stores, look like these crazy churches. So they are super clean, and if you go there, it's okay, and you're free. You have to go there, you follow, it's clean, you don't have to touch things, it's not dirty, you clean yourself, and it's a kind of salvation. It's a promise of salvation, touching it. So that's very strange for me as a European. But on the other hand, this is how it works. So I'm struggling, our theory is struggling around this question, how the hell does this work? Why is it like that? So, or how is it possible? It's very slow. Mark Zuckerberg. This random boy gets this powerful. This is a 5-hour testify before Congress, American Congress of Mark Zuckerberg. And if you look at him, he's an innocent, he plays an innocent boy. How, and I don't get this, I would not say that in Europe a figure like that can be this powerful. So it's interesting and it's challenging for me. How does it work that somebody like him got this powerful? Or our dream, this is more European, the dream of WikiLeaks, that transparency is for the good. Look at him as Assange. Or more recent, with Greta Thunberg, this the hatred and the anger that things are not innocent, that they're dirty, and this that we say it's a principal innocence of youth we should follow. I think to get that in proportions. So I don't say this is nonsense, so this is a challenge, but I would say today these things are not in proportion. And we will have to learn, and this the noble role of architecture is to bring these things into a proportion and to domesticate these things in a way that we say, okay, this is civilized. That's the motivation of our class, and it's a plaidoyer for for architecture and playing a substantial role in today's world. Okay, hope you find it interesting, and we'll follow the other tutorials.